Hello everybody, this is MobiDAX Quest video series, a video series where we teach you how you can build your own crypto trading platform from scratch. This is the video number 3, and in this video we are going to answer 2 questions. The first one is how to deploy and to configure blockchain node, and the second one, why do you even need a blockchain node in your cryptocurrency trading platform. Alright. So let's get right into it. There is 4 points why you need a blockchain node. The first one is deposit discovery. So how do you record deposits on your platform? Because everybody knows that there is a blockchain and there are transactions happening in there, and your cryptocurrency trading platform has wallets for each user. So the way you discover that deposit is coming to a user is that you're scanning every block on the blockchain to find whether any wallet address presented on your exchange was featuring in a transaction on a blockchain. I hope you understand this. I will show you a diagram of how it works a bit later on. The second one is withdrawal creation. So when a user wants to withdraw some funds, you call blockchain API and create a transaction and post it to the blockchain. So that in that way the funds are leaving your platform and going to the recipient of that user. Then the third one is deposit address generation. So before you even send funds to your trading platform, you have to generate a deposit address for a particular user. So you also would call a blockchain API to generate that address for that user. The fourth one is funds management. Funds on a typical exchange are stored in 4 types of wallets, and they are moved among those wallets using some rules. I will show you just in the next slide. So right, funds management. On a typical Peatio-based exchange, you have 5 types of wallets. First one is deposit, second one is fee, third one is the hot wallet, the fourth one is warm wallet, and the fifth one is a cold wallet. So why do you need a deposit wallet? Well, deposit wallet is used for calling a blockchain and create a new wallet address for a particular user. This wallet address and private key is stored on the blockchain node, and the wallet address is also stored on the database. So you can always query your database to get a deposit address for any given user. Then you have a fee wallet. A fee wallet is used to pay fees for ERC20 transactions. So this wallet is ERC20 only, and you need this because, on Ethereum, to create a transaction and to make it successful, you have to pay a fee. So when a transaction is created, this transaction is created when incoming deposits are collected to the hot wallet. The process of deposit collection I will show you in the next slides, so stay tuned for that. Then you have the hot wallet. The hot wallet is used to collect all the incoming deposits to one wallet, which is the hot wallet. In order to make funds management easy, you need all the funds that were incoming to your platform be stored in one place. Otherwise, it gets messy. A user deposited some funds on his deposit address, then he traded some stuff, and then imagine he deposited 2 Ethereum, then he traded 1 Ethereum, and he has like 300 USD and 1 Ethereum. However, on the blockchain, you see that he still has 2 Ethereum on his wallet. So that's why you need this hot wallet to make your funds centralized, and then based on your transactions inside of your platform, you then spread the funds. So some users traded different stuff, and then they want to withdraw. So even though if someone deposited like 2 BTC to your platform, the other guy deposited 3 Ethereum, all these funds are gathered together, and then once they did their trades, somebody withdrew USDTs, the other one withdrew different currencies. So in order to avoid the mess, the funds are usually stored in one place. Then you have a warm wallet. Warm wallet is used to store the funds when a hot wallet has reached its maximum amount. You can configure this stuff in the admin panel. I will show you later on. But basically, when the hot wallet is overfilled, you don't want to store too much money in there. You have the warm wallet to help. And also you have a cold wallet. It's also used to store your funds when the warm wallet has reached the maximum amount. And this cold wallet is typically a hardware wallet, so your exchange trading platform doesn't have access to that wallet. And this one is used to store a really big amounts of money. So in case a user traded like 100 BTC and he wants to withdraw, you would manage that withdrawal in a manual way. So you don't want to have that big sums of money be done automatically, because there's always room for error or possibility for error, and that is just too much responsibility for that big amounts of money to be withdrawn in an automatic way. So that's that. I hope this is understandable. In case you have questions, make sure to drop them down below. And let's move forward and go into detail of how deposit collection, withdrawal, and deposit address generation is made. So, deposit address generation. How does it work? I hope you see my cursor. You have a blockchain node right here. It's Geth in this case. Then you have a Peatio daemon, which is called Peatio deposit address. This is just a container running on our VM that we installed in the previous video. So that's the first video we published. If you missed that one, make sure to go back and deploy your own platform so that you'll understand what this stands for. So this Peatio deposit address daemon, it sends a request to Geth API, so it's a JSON RPC request, and then Geth returns the generated address, and private keys are stored on the node. The generated address is then sent back to this daemon, and then this daemon knows that there was an event of an address generated, and it sends that event to RabbitMQ. I will probably talk later about RabbitMQ and all different other backends that we have featured in the platform. But basically, this one is used to send messages across different applications. So how this could work? It's deposit address daemon sent an event to RabbitMQ, and then we have a mailer, for example, or a postmaster in earlier versions that can consume that event and send you an email address saying like you generated a deposit address. Or this could also potentially be used on push notifications in the application. In our MobiDAX application, for example. We haven't yet implemented that functionality, but there is a huge possibility for that. And also, Peatio deposit address reflects this on the database. So it says on the database that there is a new payment address generated for this particular user. That's how your deposit address generation is made. We will generate some addresses manually to set them into the when we are going to set up our wallets. We will do some manual address generation, so you will see how that works in a nutshell. Let's go forward. So deposit discovery and collection. Now this can look complicated. I will try to explain it as simple as possible. This is when you have already generated this deposit address. You copy it on your front end, on your base app, where you've logged in and you have a user. You select Ethereum, for example. You get this deposit address, and now from your hardware wallet, let's say, or from your MetaMask, you want to submit some funds to the platform. So that's when deposit discovery is made. So you copy the address, you go to your MetaMask, you put it in, and you send some funds, like you send 1 Ethereum to the platform. And so what is happening? Well, after you've sent that Ethereum, you have a transaction generated, you have a transaction ID. That transaction is featured on a block in the Ethereum network. And let's imagine that block is number 1, 2, blah, 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 like this one. So it contains the deposit address of your user on the exchange. Okay, cool. And here on our side, on the server side, we have a daemon. So a daemon is like a never-ending process. And this never-ending process is called Peatio blockchain. And what it does is it constantly is scanning the whole blockchain. So it's processing every block and looking for a deposit address that is on our exchange and in some block and some transaction. Then it found this block where you send your funds to the exchange. It found your deposit address, found the amount of money you wanted to transfer, and it has this event like I found a deposit. So a deposit was created, and then it generates an event to RabbitMQ that I mentioned earlier that a deposit was created. And this event is then collected by deposit collection daemon. It's also a never-ending process. This process is notified that there was a deposit made to an address on our exchange. Then what this daemon has to do is it has to collect the funds from your personal wallet to exchange, like exchange hot wallet, the main exchange wallet, Ethereum, obviously, because this is the currency we're talking about now. So what this guy does, deposit collection, is that it sends and generates a transaction, and in this transaction you have your user deposit wallet and the exchange hot wallet, and you transfer the funds from deposit user wallet to exchange hot wallet. So this guy, it sends a transaction to Geth saying, let's transfer the money from the user wallet to my main hot wallet. And then Geth posts this transaction to the blockchain. Then once again, we have a new block where we see the funds transferred from user wallet to main hot wallet. And then we have another event generated is saying that deposit was collected to the platform. It is no longer on your personal user wallet. It's already on the hot wallet of exchange. And then this event is sent to, again, Peatio blockchain daemon because it discovered this new block of deposit being collected. And it changes the state of the deposit. So previously the deposit was created, now the deposit is collected. This is the final state of a deposit. It was discovered and submitted and collected now. So now we can work with these funds because they are already submitted to a user account. We have them on our hot wallet. User can do his trades, whatever he wants. We already have them on the hot wallet. It's all good. Okay, I hope this is understandable. It's a bit of a complicated process. I tried to make this diagram as understandable as possible. But if you have questions, make sure to ask them. We will make sure to answer those. All right, so let's move forward. Let's imagine we deposited some funds, we made some trades, we have converted them to different currency. Let's say we bought some BTC and we have some Ethereum remaining and we want to withdraw them back to our MetaMask. So this is the process that we will go through when we want to withdraw those funds. Okay, so let's look once again. So we still have our Peatio blockchain daemon. It's constantly scanning the blockchain. We have our Peatio withdrawal daemon. So sorry, I made a mistake. Here it will be not a deposit address, it will be Peatio withdrawal daemon. And what this daemon does is once we ask him to withdraw some funds back to MetaMask, it creates a transaction where we withdraw funds from our user account to the MetaMask. The transaction is the address of sender of the funds will not be our user deposit wallet, it will be the hot wallet of the exchange. And the one that will receive the funds will be our MetaMask wallet. So it sends this transaction to the blockchain, to Geth, and Geth says, okay, I will post this transaction to the blockchain. It's going to be in one of the new blocks that will be generated. And we can see this yellow block. This is where basically this withdrawal will be featuring. But now before that, we should understand that once transaction is created of this withdrawal, we will see it on the database, that the withdrawal will be in confirming state. So the withdrawal is created, but we don't know yet whether it's successful or not. So we know that it's created, but we'll see whether we can say that the transaction was successful or not. This is specific to the blockchain. I hope everybody knows that once you post something to the blockchain, you're not 100% sure that it will be in the future block. There can be a situation where this transaction will fail, for example, or the block will not be mined. This is specifics of the blockchain. I think we can talk about it in the future videos. If you guys are interested, let me know in the comments down below. But if it was featured in the block, our Peatio blockchain daemon will pick that up. And you can see here, right, I see that there was a withdrawal made to this particular address. I already know this withdrawal because it's already in the SQL. It's already in the database, so I know it. Now let me see whether there were like 6 blocks after this one, whether I can say that this block is true, it's correct. If there were 6 blocks after that, we can say that the block is fine, and we can send a withdrawal succeeding event. Like we can say this withdrawal is true, it's successful. Let's reflect that on the database, and let's say that these funds are already out of our exchange, and we're happy with that, and we know it. So this event is here in the RabbitMQ. Once again, as I previously mentioned, we can consume from RabbitMQ these events and send a mail to our user notifying your withdrawal was successful. Also, as we understood the withdrawal was successful, we can always reflect, we should always reflect that on our MySQL database. All right, this is the process. I hope this is also understandable. If it's confusing in any way, or if my explaining is not good enough, let us know in the comments down below, and we might create a separate video and go in depth with this, so that everybody understand how this works under the hood. I think that is quite important. So then the next thing that we have to do is that we have to deploy our own Ethereum blockchain node. This deployment will be based on Geth client, and after the deployment we will configure the blockchain on our exchange platform, and we will also configure the required wallets and create a currency for that. And we will see if after this we have successfully created a currency, a blockchain, a couple of wallets, and whether we have our deposit address generated for us. That's the plan for the video. So let's get right into it. Now, in order to deploy a Geth node, we will obviously need to create a virtual machine. In this case, I will use a droplet on DigitalOcean as usual. So make sure to have your DigitalOcean project ready. In this tutorial, I will not explain how to create a project and so on. There's plenty of resources out there, so I think you will be fine with that. However, I will tell you how you need to create this node. So let's check the requirements. This is the minimum that is needed for this node. I think I will use the minimum here, but I advise you to stick to the recommended ones, especially for mainnet. We will use the testnet one right here, but for mainnet, make sure to use the recommended resources. Otherwise, your sync might be way too slow, or your actual node might not be that stable. So for this tutorial, let's use this one. So let's create a droplet right here. I think Ubuntu should be fine. 8 gigs 4 CPU. I will stick to 4 gigs to CPU. That's what they say. Yep. And 4 terabyte transfer. How much storage? 80 gigs of storage. That doesn't seem like enough, but I will not be waiting for the full sync. I just need to show you how you need to configure the wallets. And the sync process, it just goes in the background and you just have to wait until everything is fully synced. So yep, that's enough. And also for sync storage, you can add another volume and you can mount that volume inside the VM in order to not use whatever you're provided with here. So I mean, let's add the volume. I'll show you how this is made. So let's add 50 gigs. ext4 is good. Automatically format and mount is good for me. So let's stick to that. For this, I will use London. That's all okay. I'll add my SSH key so that we can SSH to this. We don't need any tags. The project is that. Yeah, so seems to be all good. I recommend you to enable backups. I will not do it right here because it's just a demo tutorial. But make sure to select all the best and the most stable settings, especially if you're if it's not your test environment or development environment. All right, so let's wait until that is finished. So this is all done. Then you have a setup or running modes and all of that. I'll explain a little bit later. The way we are going to be running this node is we're not going to build directly from the source code or anything like that. We will use a Docker package because Docker container, sorry, because that's like already available right here in front of us. So why wouldn't we use that? I think it's a neater way. You don't have to install any dependencies or go through the nightmare of installing them or resolving any conflicts or anything like that. So we'll use this Docker Compose file, but in order to work with Docker Compose or Docker in that matter, we need to install it first. So we'll go through the same steps as we did in the first video and install Docker and Docker Compose. But let's see whether this has finished already. Yep. So we have it right here. So let's copy the IP and let's SSH. So that's under root. Let's go. Yes, please. That's my passphrase for SSH key. All right. So we're in right here. I recommend you also creating a different user here and adding it to the Docker group. I will skip that step just to make this video shorter because I'm already out of the timeline. But let's install our Docker and be a little bit quicker with this. Sorry, it's uninstall. Let's go. Install method. Yep. So let's do this. So this is just a matter of copying and pasting the commands. And it usually works out of the box. If it doesn't, you probably did something wrong. And by the way, all of these links will be available in the description. So if you've missed something or you want to go back, it will be available for you. So let's also add the repo. So these commands should execute one after another. So I can just paste them in and then I will probably speed up the video as well, just to make it, go faster. So yeah, I think this is enough. Let's give it a few minutes to think. And then we'll see. All right. Now the Docker is installed. Let's also install Docker Compose. Let's make it executable. All right, let's see whether it's available. Yep, so cool. Now we need this. I'll send the link down below. So this is my Docker Compose. You can just download it like that. And we have it right here. And let's see what we have here. Well, we have ports and we have volume also here. The volume is /geth, and this is where our blockchain data will be. I don't think we have that /geth. We don't have it. So we'll need to create that directory. Yep, but not here. Like that. And so everything, all of our blockchain data should be right in there. But also, let's see, well, I've added a volume to show you how you can, instead of using the main VM volume, how you can add a different one and store the blockchain data in there. So let's do just that. And here you can see that volume, it was mounted on a specific path for me, but I want it on /geth. So I will do like that. I will unmount what DigitalOcean has mounted for me, and I will do dev sda to /geth. And now let's see. Now it should be mounted to correct, to the correct directory. So we can start our geth VM. But before that, let's check some configuration. Right. So sync mode fast. Let's see. I want this to be running on the Rinkebai network, but I think this one is running on the main net because we didn't specify the network. So let's go into the documentation and let's see the network. Right, let's see how we can specify the network. Let's go with geth, sync mode. All right. So, I mean, this can happen, you know. Let's go to documentation of geth, getting started, sync modes, networks, Rinkebai. How do we specify using geth? Connected to the network. Okay, so you have to use like this in order to specify what network you want to be running on. So I will add that. Let's add it right here. Rinkebai. So now you can see that we will be running on the Rinkebai testnet network. So let's save that. Okay, and let's start up our geth. Okay, let's see whether that was successful. Let's see the logs. Okay, so as you can see, it has created and it's looking for peers at the moment. So it has started it has started, and now it's importing new state entries. But how do we create wallets? Well, we can do just this to attach to our geth node. All right, let's do like this. 545. To remove. Okay, let's see. Let's do that first. Let's do sh. All right, so get attach. Okay, so now we've attached to this node, and we can see how it's syncing. I think it's like this. Yeah. So you can see the status of the sync. So it has already synced 94,000 blocks, and the highest block is right here. So we are a little far off, but it takes time, you know, to get it all synced. Now, how do we actually configure this stuff? How do we set it into the platform? How does it work? So what we need to do is we need to open our Tower admin panel and sign in with an admin account. Then in settings you can see blockchain right here. So we will create a new blockchain. We'll give it a name ETH Rinkebai. Let's give it a client of Geth. So here you can see the supported blockchains as well. So let's give a client of Geth, height of 0. It will automatically be updated once there is more and more height. The Explorer address we need actually this one. So let's go to rinkebai.etherscan.io. And this is the block explorer for this particular testnet. So let's go right here. This we want, so we want, let's see TXID, right? So we do TXID, right? So this is for transaction and this is for address. Okay, then minimum confirmations is how many blocks have to be passed so that we can say that withdrawal was successful, for example, or deposit was collected. This is the minimum confirmation. So for example, if a withdrawal is present on block 5, we will wait until block 11 and then we can say that that withdrawal was successful. Now we need to also provide an IP. So for that we go to our DigitalOcean, we copy the IP right here, we go here and we specify like that. Let's submit. Height, let's start with 1. Submit. We already have key Rinkebai, so let's go Rinkebai 2, for example. And there you can see, so our blockchain is available right here. Now I have a suspicion that this IP is not accessible here, or we don't have a port whitelisted, which can be the case. And in this matter, you have to be very careful and only whitelist the important virtual machines. So for example, you don't want anyone on the web to have access to your mainnet Ethereum blockchain node. So let's see, if this is not updated, that's probably the case. So what I'm going to do is I'm going to start a new session right here, and I'm going to send a JSON RPC request to this node to see whether anyone from the web can actually query it. So for that we can go back here to documentation. Let's see, JSON RPC API, ETH. Let's see, do we have ETH call? That's not what I need. Let's see, personal. Yeah, well, let's query ETH syncing JSON RPC. So I think this should be available right here. Let's See, and also open this link and this link. There should be an example of CURL request. I just don't remember how you should specify it. CURL examples, yeah, that's what we need. ETH syncing, right. So that's exactly what we need. Just we need to specify our IP, and let's go right here, copy it, right. Okay, so we need another header, -h, content type, application, JSON. Yeah, so yeah, you can see current block, so we have access to this. So this should be working. Let's see, we have a height of, let's specify 5, for example. Let's go reset. So this should be able to update. But let's also translate current block. Let's go hex to decimal. So I can go just easily like that. Yeah, so the highest block should be 542,000. And we see 5 here. So this could also mean that there is a problem with our blockchain daemon. So like, there you go. You already have some hands-on debugging. Right. So what do you need to do? You need to SSH to your virtual machine of your server, and you need to restart your blockchain daemon. That's the easiest and the first thing that you can do when you encounter a problem like this. So let's see if that helps. Let's recreate the daemon and go back here. Alright, so it's not picking up our height yet. Let's come back to that a little bit later. As of now, let's see how you can create a currency using that blockchain. So let's call a currency ETH ring. Let's give it a code, ETH ring, symbol, whatever, just coins, subunits 2, precision 2, and blockchain key. So see, we have our blockchain key right here, and this is our currency, a new currency, and you specify your blockchain key that we just used. So let's create it. Now you can see we have our currency right here, and we assigned the blockchain that we've just submitted, which is right here. Let's see the logs of blockchain. The runner is up to date. Okay, so you can see that it has created a runner for our blockchain that we've just submitted. So that is good. So it should be updating. Right. The next thing that we have to do is we have to create wallets, and here you can see exactly those types of wallets that I've previously mentioned. Is a fee wallet, warm wallet, hot wallet, deposit wallet, and optional cold wallet. So in a similar fashion, we can add a new wallet, ETH ring buy, for example, deposit. We select the blockchain key of the newer added blockchain. We select get. Currency ID is our ETH ring. The kind, this will be deposit. Maximum balance does not matter here that much. And the URI is basically your node that you've just deployed. So let's copy this where we were, right here, and 8545. and this is the secret for the wallet. Now let's go back to the node, which is right here, and let's create that wallet. So to create a wallet, you have to use this method, personal.new account. So let's do that, .new account. Right, passphrase, let's go change me. Okay, and let's see. Right, so we have our wallet address. Let's paste it in here, enter the secret. All right, and just like that, we have our deposit wallet. We want it enabled. Okay, so let's check right here whether we have a deposit address generated, and yep, you can see it. We have a deposit address, so you can already submit your funds right here. The deposit will be collected and you will see it right here as your balance. All right, so let's see once again how is the our block. Now let's see if our blockchain is moving. So let's go right here. Yeah, you can see that it's already updating and pretty fast. So yeah, it will keep updating until it reaches the highest block, and we have also a parity deployment right here that has already reached the highest block. So this one is trying to catch up quite quickly. And yeah, so there you have it. We have added a blockchain, a currency, a deposit wallet, and in the same manner you can also add other types of wallet I've already mentioned, and you can see that we have our deposit address generated, so we can start working with this. And once you also add the hot wallet, the fee wallet, you can also do some withdrawals and test that functionality as well. So that's it, guys. I hope you enjoyed this video tutorial. If you have any questions, make sure to drop them down below and join our Telegram community chat, because lots of help is available over there. So do not miss out on that opportunity. Well, thank you for watching and see you next time.